So I'm going over the marginal cost and marginal benefit model, and this model is very broadly applicable, but for this example I'm going to talk about it in the case of a pharmaceutical company thinking about innovation. So for marginal cost and marginal benefit, we're going to graph our total benefit and total cost on this axis. So both of those, total benefit and total costs, go up here. And one thing we need to be sure if we're going to put them on the same graph is that they're in the same units. And you might think, well, total benefit for these drugs might be revenue for the company, or it might be, in other parts of the model, it might be utility. Total cost might be money that they have to spend paying employees and buying equipment. It could also be effort or pain. Cost can be measured in a lot of different units, but you can actually go through a proof that will show you that it's possible to put any kind of units into dollar units, whether it's utility or pain. You can always come up with some way of translating that, theoretically at least, maybe not practically, into dollar units. So it's okay to put these on the same axis. And we have quantity here, which might be quantity of dollars invested in developing new drugs. That's going to be the example we'll go through today. And we have the concept of diminishing marginal benefit. So this is our total benefit curve, and we see that as we add more and more dollars of investment in new drugs, the total benefit, which might be revenue to the company, is going to decrease. So let me just put this concept up here. Diminishing marginal benefit is a key concept behind what we're doing. And so why is there diminishing marginal benefit in this case? And the reason for it is because a good manager of a firm is going to spend the first $100,000 that they invest on the most promising project they can come up with. So they'll look into all different types of drugs they could develop, and they'll invest their money in the one that's most likely to have a high benefit. Of course, if they get a second $10,000 to spend, so we're out here, they're going to research all the projects and choose the second best project in terms of the expected benefit. And because the managers choose projects first with their first money that are most beneficial in terms of payoff, and as they go along, they'll choose the next best beneficial program. Because of that, and because not all programs have the same benefit, we're going to get diminishing marginal benefit, and a curve will look like that. Now our cost curve, our total cost curve, total cost, has the property of increasing marginal cost, which is kind of another property very similar to diminishing marginal benefit. That's increasing marginal cost. And so the question is, why are costs increasing? And the same basic logic holds. They know if they're going to invest in a project, that's going to require hiring scientists and renting equipment and hiring janitors and things like that. So the first money they'll spend will be using the most efficient resources possible. So the lowest wage worker for the amount of output they're going to produce. So if you hire up the newly minted PhD physicists and chemists and bioengineers, they're going to work on your first project. But if you already have 5 or 6 projects going, chances are that you've used up a lot of the really efficient, meaning smart people for the amount of money you pay them in wages, and you're going to have to dig a little bit deeper to find people. You might have to pay them a higher wage to attract them into the industry. Maybe they're working in academia and you need to attract them over to your company. So as you add more and more resources, they're going to get more and more expensive. So the concept behind both of these curves is the idea that a good manager is going to choose the most beneficial and least costly resources for their first project. And for the second project, it's going to be the second most beneficial and second least costly. And that's why we have this shape to our total cost curve. So how do we solve this? Well, we know what the company is going to be trying to do is to maximize benefit minus cost, and they maximize that by choosing the quantity of dollars they're going to invest in new drug development programs. And we can see that on the graph. We can see at this point, what is the benefit minus cost? It's going to be this distance here. There's a pretty big benefit minus cost. And that we can find that for every single point on the graph. The distance between benefit and cost gives us the total benefit minus cost, which is what we care about. Now at this point here, we might think that would be the point we should choose because it's where two curves cross, and sometimes in economics that's what we do. But that doesn't work here because at this point, benefit minus cost is equal to 0, and we don't want that. We would actually prefer benefit minus cost to be greater than 0. In fact, we want to maximize it. So the maximum point is going to happen where the bulge in between these is biggest, and that will happen where the points are tangent. So these are, I'm drawing parallel curves here because the points of tangency will be parallel at that point. And that's why we use calculus and in economics a lot, is because these points of tangency end up helping us maximize things. So this will be the point where the quantity of dollars we invest in new development projects will maximize our benefit minus cost, or in this case probably our profit, which is revenue minus cost. So let's just do one last thing, and that's let's map this onto our total benefit minus cost graph. And we see at this point we chose our benefit minus cost will be maximized. At this point our benefit minus cost is 0. And if we're just mapping the difference between these two curves onto this map, that's what our graph is going to look like.